You're not going to want to miss this episode of the AI Show, where we're going to be talking about advancing through the LLMOps maturity model with Azure AI. Let's jump in. Welcome. We are joined by Satu and Rotesh. Thank you so much for being with us today and showing us the cool things you're working on. Why don't you give us a little introduction to who you are and what you do?
Thank you for having us, Cassie. It's exciting to present our work that we have been doing for past 1 year. My name is Setu. I'm based out of sunny Singapore. It's almost midnight for me. We don't get snow like you, Cassie, so it's sunny all through the year. So it's good fun. So I'm part of the AI GBB team or the Global Black Belt teams, and our team specifically gets involved in onboarding a lot of AI solutions with our customers. And since over the past 18 months, that's what we have been doing, a lot of work around OpenAI, building LLM applications, and we have kind of combined our learnings with our colleagues from ISE as well and the CSU into building this accelerator that we are going to present today.
Amazing. And did you want to introduce yourself as well?
Oh, yeah, absolutely. So great. Hello, everyone. I am Ritesh, and I am speaking to you from London, United Kingdom. And it's getting better, yeah, compared to your snowy city. So it's getting much better. And I'm part of a group called Industry Solutions Engineering, and we help our customers with the latest and the greatest on Gen AI, LLMOps, and MLOps. And we make sure while we do that, we also scale them so that by creating the relevant assets and IP so that we can not only use with the customer, but we'll bring it to other customers as well. And also provide relevant and appropriate feedback to the product group on the features and the ask from the customers, providing appropriate signals to help and shape the product and services that we bring on Azure, especially to AI and Gen AI as well. So happy to be here and looking forward to talking on LLMOps to everyone.
Yeah, this sounds awesome. I can't wait to learn more. So let's jump right in. I think we have some slides here to kind of set the level for people that might be new to it and learn a little bit more about this journey, right? So let's take a look at that.
I hope you guys can see the presentation.
Yep, we can see it.
Yeah, so I have a few slides, and I'll promise I'll not take too long onto this. I'm sure you guys are excited about watching the demo and what we have on there. But I'm sure as we started this topic earlier, there's a lot of interest around operationalizing language models. So we'll dive right into that. And for those who probably have seen some of our previous work, we had talked about MLOps as well. So we'll talk about how companies that have adopted MLOps or our accelerators early on, how they can transition working with this accelerator as well. So as we work through this, right, you would have seen that there are a lot of challenges to harnessing the power of generative AI, right? When you work with generative AI application, it involves a lot of advanced products, right? Be it frameworks, be it models, which requires specialized expertise itself. And when you kind of think about operationalizing the LLMs, there are a lot of challenges in terms of privacy, security, making sure that the AI models are well grounded. And a lot of developers, frankly, often lack the necessary expertise and tools to properly evaluate and scale such solutions. And hence, having a right operating model becomes very important. So when we talk about the operating model for your organization, it always comes to, what is the workflow that we are going to follow? And oftentimes it's said that being intelligence driven means that you want to have control of your operations with secure, predictable, and flexible service delivery and capabilities. You want, or rather you need innovation to be able to provide faster development and rollout of your business use cases through adoption of various cloud services, be it Azure or some other ones. We often do that because we want speed, we want agility, we want to make sure that we reduce the time to market to ensure that we stay competitive. All this while, you want to make sure that we are controlling the cost while limiting the upfront investment and scale quickly without limit. And that's what having the right operating model will do for you. And that's what is important as part of working on the LLM ops part of it as well. We talk about this in terms of people, processes, and platforms, right? And LLM ops, the framework that we have been developing at Microsoft for operationalizing these environment, encompass all these three things. For those who are new to LLM ops, at its core, it's basically a synthesis of the DevOps methodologies that have been adopted specifically for the domain of large language models. And not necessarily large language models, these can also be done for what is now coming up as the small language models as well. So with the help of the continuous integration, which we call CI, and continuous development, CD, methodologies, we want to make sure that we are able to streamline the testing, evaluation, and the deployment of LLMs. We want to do that because as the LLMs evolve, their integration into the product and various services is seamless and efficient while maintaining high standards of quality and performance. And one of the key things that we talk about in LLM ops is the focus on repeatability and consistency, just like you have seen it in DevOps as well. So by establishing a clear and well understood process, we facilitate a model of operation that not only ensures accuracy, but the reliability of LLMs as well. And these processes that can be replicated across various teams, across the organizations as well. And as I said earlier, right, LLM ops or DevOps is a collaboration between people, processes, and platforms. And the way we do that is by creating a shared language and common practices that bridge these various practices and expertise that lie within the organizations. And you want to make sure that depending on the organization, we are able to adapt this to very specific use cases as well. And this is the customization is what will enable organization to extract more values from their LLM application itself. And hence, this whole idea of LLM ops, where we are building a model that not only accelerates development, but also guarantees the adaptability and sustainability of these LLMs, especially now that they are evolving so fast, so quickly within that.
That's a lot of things to put together. Oh, good. This is a really great view of seeing how those pieces come together, because they're hard problems to solve. So, and it's like definitely an adaptation from maybe where they were with their traditional LLM. So please tell us more about this.
No, and specifically, right, when you work with this LLM apps itself, right, they are a bespoke process. You start off by picking up models, you're training up your prompts, you're creating this pipeline. There are data sources that need to be built in, and frankly, it's for a lot of customers, right? They find that a lot of these processes that we talk about that are required for building these LLM applications, they are not scalable, right? And they are looking for guidance on how they can take their existing DevOps or MLOps process that can be augmented to cover these new workflows, right? So even though generative AI introduces a lot of these new techniques, it also comes with its own set of challenges that are difficult to kind of work through that. And that's why we came up with this whole idea of how can we adopt LLM ops and what does Azure on its platform has to offer when they start working through this. Right, last year when we kind of did ML ops, we talked about pipelines, we talked about experimentation. Those principles are still important today, right? And a lot of data scientists will find this more naturally to do rather than the developers. But the idea is that we want to make sure that anybody within the organization is able to set this up and have a control such that they can implement the safeguards that their business require as well. So that's why it becomes very important. And Azure AI, Azure AI Studio play a very important part in that.
Awesome. Yeah, I agree with that. And it's also interesting how roles kind of change, right? As the processes evolve, the roles to make those things happen change a bit as well.
Yep. And that's why we say, Azure AI is the place for all things language models. I'm sure some of you have played around with this, but just like other platforms, we allow for discovery of various large and small language models from not only providers like Azure OpenAI, but things like Facebook, Mistral, and others as well. So now you can take those models, take those language models, build a business specific pipelines that leverages those models or the fine-tuned models itself, and be able to safely and responsibly deploy these pipelines into various business applications, right? And the demo that Ritesh is going to talk about is going to be with Promptflow. With Promptflow, we bring the rigor of developing professional grade LLM pipelines that can be version controlled along with the prompts, and then take those pipelines and with the help of CI/CD pipelines, have an optimal management and deployment as well. That's why with AI Studio and Promptflow, we are encouraging collaboration not only with the data scientists, but with ML engineers, app developers, and data scientists as well to bring their skills to collectively enhance the AI system quality as well. And then with the Microsoft commitment to responsible AI, we have built-in governance, we have built-in tools that ensures that LLMs are developed not only the LLMs that are developed are not only secure and trusted, but adhere to specific guidelines and the best practices that the organizations have.
Yeah, and that's
And
kind of speaks to the whole ops thing. All the people and process come together, right? So the
right,
tooling together, the people and the features that we need in order to deploy these responsibly and correctly.
sure. And promise this is my last slide on this, is talking about LLM lifecycle. I'm sure a lot of this would be familiar to a lot of our users who have been watching this channel. Versions of this we have presented in various formats. Like with all problem statements, right? It starts with the business need, right? And that's what forces us into figuring out how are we going to leverage some of these things? How are we going to work with prompts in there? So it starts off with the left-hand side where we start off by identifying which LLMs are going to be useful for our needs, right? Which prompts are we going to play with? Once that is done, we start by building up our applications, right? This is where there are a lot of these techniques like retrieval augmented generation come into play, right? We are going to play with a lot of prompt engineering and fine-tuning techniques as well. As we encounter challenges, we'll put in more exception handling, make sure that our project stays on course. Lastly, once that is done, we'll make sure that the model is performing as we require, because that's going to be critical for the success of the application. Now, AI Studio, we have an evaluation pipeline as well that allows for systematic assessment of those pipelines as well. We gather those insights that inform our iterations and ensure that our application is robust and aligned with our objectives as well. And then as we prepare for deployment, operationalizing the LLM pipelines is going to be our focus. We implement content filtering for quality and safety, make sure that we have robust monitoring systems. We also put in controls for maintaining the quotas and the cost. And we make sure that the feedback that is coming in there is feeding the continuous improvement that goes along with the process. Now, whenever it's reverting to new prompts, new LLM, each step is going to be integral in developing an efficient LLM application. So with that, I will hand it over to Ritesh, who will kind of show us more practical aspects of what I talked about and how we do that with Azure AI. Over to you, Ritesh.
Great. Thank you, Setu. And just would like to confirm if my screen is visible.
It looks like I can see a preview here. There we go. That's what we want to see.
Okay, that's great.
There we go. Now we can see it. Yep.
Perfect. Good. Great. Thanks a lot. So now, actually, now we get into the thick and thin of what LLMOps is all about. So as we heard, LLMOps is a lot of things going on with LLMOps, like DevOps, MLOps, good parts of them coming together, people, process, technology, platforms, all coming together. And when we talk about LLM ops, obviously it's large language model. It encompasses a lot of different processes like LLM ops for RAG, LLM ops for fine tuning your models, LLM ops for pre-training, LLM ops for prompt flow. Now, prompt flow is one of the leading orchestration tool that helps you actually orchestrate not only the experimentation, evaluation, and deployment of your entire solution or Gen AI application. But it also helps you actually to do prompt engineering as part of it. So when you come to prompt flow, so basically when you are within your when you are within your prompt AML environment, you can work with Promptflow. But Promptflow is not only available within Azure Machine Learning Studio, it is also available through your Azure AI Studio. So there are two ways you can access Promptflow, either through Azure AI Studio or through basically coming to Azure Machine Learning Studio. So if you come to your portal, generally you would see on the portal, you would see Machine Learning Workspace. And if you click on the Launch Studio, you get this screen. And with over here, you have the prompt flow, and you can keep creating flows from here in various different configuration. It's the same thing when you come to Azure AI Studio. You can click on prompt flow, and from here you can start creating your flows, and you can view your runs and everything related to prompt flow. So when you are in prompt flow and you click on the create, you are basically given three choices to create a standard flow, chat flow, and an evaluation flow. And the main difference between them is that standard flow is in actually the orchestration flow that you would like to deploy, so which takes an input and generates an output, and it has the logic in between. Chat flow is a add-on on top of standard flow in the sense that you could also maintain history with every request, so that you when you are providing a response, the response is based on not only the current question and answer that's going on, but also from the previous session chats that has happened in the past. And the evaluation flow is quite interesting because it's very different than the standard and the chat flow. Evaluation flow is all about evaluating the goodness or the way your standard flow is working. So you have written your standard flow, you have an input and an output. You want to test and evaluate your standard flows in terms various different types, like how good the standard flow is in terms of accuracies or recall or precision or groundedness or relevancy and things like that. So it's about evaluating your standard and chat flow. So we have these three flows, and any of the flows you can use it. And when you click on the create button, it actually creates a flow for you, and which is a template that you get and you can modify. Obviously, you can do the same thing from Visual Studio as well. You get the same look and feel on Visual Studio, and it generates quite a few files, which is obviously backed up by the storage account. And as you can see, we have inputs, we have output, and then we have a set of Python nodes and prompt nodes, which we can use it to build a logic. And they consume our inputs and generate an output. So, and when we have this prompt nodes, we can have multiple variants. Like, for example, when you write prompts, you can have various different prompts, and each prompt could vary not only in text, but they can also vary in terms of how you have configured your OpenAI large language model, and how you want to send those parameters, including things like temperature and things like that. So this is how generally you work with prompt flow. You write your flows, and then once you have written your flow, then you can quickly come back here and say, I want to create an evaluation flow which will work with my standard flow, and then I can bring them together. So think of your standard flow as an experimentation that you want to do, and think of your evaluation flow as testing your standard flow. And then eventually, once you're happy with these, you can anytime come to the flow and say, I want to deploy this flow. And then the deployment actually happens at the endpoint, which you can open it up for public, or which could be internal in nature, depending on your use case.
Can I
Now,
add something here too?
Yes,
Just I wanted to add that we can do all of this locally in VS Code as well via the prompt flow extension. So if you prefer to use, the development tools like VS Code and do that versus using the portal, all of those options are available. So you can start, and you can then, push them to portal and deploy, or to the AI Studio and deploy, or you can, continue to do that through your DevOps cycles, or LLMOps cycles, like with GitHub Actions or whatever tooling you use.
absolutely. So being said that, so you can see that there's a lot of things that happens over here: experimentation, evaluation, deployment. Even if you want to do it through Visual Studio, building your logic, and then making sure you're able to experiment with different prompts, you have variants for prompts, and then finding the right prompt, and then evaluating them, and then deploying them. You want to take this to production. So there has to be a method, a process well defined that can take you through multiple different stages, environments, and to the production as well. And that is where the LLMOps for Promptflow come into picture. So we have this repository called LLMOps Promptflow template, and this repository provides you two different ways of taking to production, either using Azure pipelines, Azure DevOps pipelines, or through GitHub. And it provides you with full documentation. And you can think of it as like a platform, because you can not only bring flows over here, multiple flows, but you can also bring both the evaluation flow and the experiment flows. So over here, you see there are three different examples: math coding, named entity recognition, and web classification. You can bring in as many use cases as you need within this repo, and all you will be able to execute and manage through one single platform. All of these examples that you see here are part of the Promptflow actual examples that you can go to the GitHub Promptflow webs repo, and you can see all of them over there as well. Now, I have cloned this repo locally on my system, so you can see that over here. And what I did was, actually I did a series of small PRs to help you understand how to work with this repo and be successful with LLMOps and Promptflow. To do that, what the initial few steps that I did was, I actually cloned this repo into my own personal GitHub repo, and then once I forked it into my own, and then I obviously cloned it into my local system, and from there on I started configuring and using it. To do that, there are a couple of documents that I would like to point you out. One is, within the documents, you have the docs folder, you have the Azure GitHub, Azure DevOps, and GitHub Workflows both over here. So this is the documentation as to how to do setup for after you have created your own repo, and you have forked it, you have cloned it. What are the steps you need to do to configure to make it run? The similar steps are there for GitHub as well. So if your choice of orchestration or CI/CD is Azure DevOps, you should follow this. And if it is GitHub, then you follow this particular link. And obviously, this is a public website, so you can obviously go here and look into it as to how this happens. I will take you through some of the important steps that needs to happen as while you do the setup. But you have to keep this in mind that make sure that the configuration is right to make it work. So once you have configured it, as you can see here, then I have this repo over here. And I did a series of pull requests. There are three over here. And those three pull requests, as you can see, I just did it today for the demo purpose. And for each of these three, there were a series of pipelines or actions, workflow actions that were GitHub workflows that were executed. And we'll go through them as to what happened and how things happened over here. Let's take one of the examples. We have the web classification. What does web classification does? The web classification is responsible for taking a URL and do a classification for me. Let's see some of the sample data for this. As you can see here, that we have given three different URLs. Each URL has an answer. So this is a channel. For example, this is YouTube is a channel. This is basically related to academic. This is all where the research papers are there. And this is an app store, right? So if we provide this as an input, we should be able to get an answer and an evidence based on just the URL of it. So this is just one example of it. Named entity recognition, for example, if you give an input, like for example, the software engineer is working on a new update for an application, it should give me, if I provide, I am interested in finding the job title within this sentence, then it should be able to provide you that there is a job title called software engineer. Similarly, math coding, you give a math problem to it, it will solve it and give it to you an answer. What does an end output look like here? So if I come here and I say new chat, and looks like over here, let me give a URL, for example. So come here and I say, what is this? It gives me, oh, it's a math problem. So let me copy the math thing. So come here. So
Are we looking at a web front end for this deployed?
Yes. So this is an example. So I have a solution that I've deployed using the LLMOps template. And this is the output that I'm expecting. So you can see that divide 20 by 5, and I get an answer 4. And I also got the Python code that this is what you should be writing to actually get an answer. But then how did I come here? How did I have a website automatically? The only thing I had to do was come to my math coding after I cloned it, make sure that I have configured this repository well. And what did I do? I came to my LLMOps config. I have multiple environments over here. I have a PR environment, I have a dev environment. So what we do, we come up with few pipelines out of the box for you. So if you look at the GitHub, there are workflows related to build validation, and there are workflows related to math coding, named entity recognition, and web classification. So we have three use cases. All three, we have a CI and the PR pipelines for them. The PR pipeline is used when you actually do a pull request from a feature branch to your dev branch. Then at that point, you would like to validate the code. You would run the unit test, code quality, and documentation, and all of those kind of things. Those gets validated within this pipeline. And once you are ready to merge your PR from your feature branch to your dev branch, and you're merging it, at that time the CI pipeline runs. The CI pipeline will make sure it not only does what the PR pipeline did in terms of validation, but it will also do complete experimentation, evaluation, and do a deployment for you, depending on how you have configured it. So how do we do all of those configurations? So if we come to math coding, for example, you would see we have LLMOps config. Within LLMOps config, we can define as many environments as we want. We have a PR and dev. We can have a test and a prod as well if you want. And for each of them, what's my key vault name? What's my resource group name? Which workspace we want to execute? And what's my standard flow? The standard flow that has the entire logic, and how I want to evaluate. Where are my flows? As you can see, I have a flows folder here, and I have a math evaluation flow, which matches to this, and matches to this, and I have a math standard flow, which matches to math evaluation flow. So all good. Now, the rest of the things that I need to configure is how I want to use my data. So I have a data over here. I have a test data and my experimentation data. I want to use this data, so I need to configure my deployment as well as my data config. So I can say I have a data in which I have a PR data, and the data file is math.jsnl, which happens to be here. And I have some experiment test data, which I want to use it for experimentation, which also happens to be test data over here. So I'm just defining some mapping over here to make sure I can use that data within my pipelines. I have my configuration.
Sorry, quick question. So the flow mapping was for your prompt flows that you've created for the different solutions, right? And then these are your data mappings for the inputs in order to run those.
Absolutely. So I have my flows. Flows need input data. This data comes from here, which I've defined it as part of my data. And once this data mapping happens, the next thing I need is how I want to deploy. And those deployment configurations are here. So we support multiple deployments. You can deploy this as part of Azure Manage Endpoint. If you deploy this as part of Azure Manage Endpoint, you can see that I have few endpoints over here. And named entity recognition endpoint, as you can see here, has been deployed. And it has two deployments. So there's one endpoint having two deployments, and we have a blue green, which means a AB deployment. That is also something that you can do through this repository. And once you've done the deployment, you could do also Kubernetes endpoint. So not only Azure Manage endpoint, you can do Kubernetes endpoint. You can do a web app endpoint as well. So when you do a web app endpoint, even what it does internally is creates a Docker image, pushes to a container registry, and then it provisions a web app and then ensures that it's able to pull that image and be ready to be used by your customers. And this example that I showed you was an example of a web app. So this web app that you see here is actually available as part of your as part of your deployment, which happened automatically after I ran the entire process. So how do I run this entire process? Let's go through it.
Let me just summarize quick to make sure we're all keeping up. So the managed endpoints that you showed in the ML Studio, those were our prompt flows that we've deployed via the pipeline, right? And then you have another pipeline that's deploying a web front end that you've created that's going to consume the endpoints of that were created in Studio. Yes. Correct?
That's okay. Correct. And just to show you an example of it, you can always come to your pipelines and say, I want to run a new pipeline. You need to provide which environment you're working with. It's a dev, stage, prod. Which flow you want to execute. In this case, it's named entity recognition, or it could be had been math coding or web classification. And then you say where you want to deploy. You want to deploy on AML, you want to deploy on AKS, or you just want to generate a Docker image and do nothing else with that and push it to an ACR or container registry, or you want to deploy to a web app. So once you have these in place, you just have to say, I want to do this over here, and then run. Automatically, this entire flow will run. And when you run this flow, it will look like this. So let's say, for example, show you this. It will do your entire experimentation and do the deployment all together as part of the pipeline. But let's go through step by step on this. You have any questions?
I do have a question. So you were showing that we could do AKS and we could do Docker, and then we used the endpoint. So which are those all in ML Studio, or are those separate? Are those, you know what I mean? What I'm saying, like where are those configured in the actual product in the server?
Not all are on ML Studio. So for example, when you come to ML Studio and you say, I want to create an endpoint. So like this, for example, and you can create endpoints from here. But when you are selecting an endpoint, there are two main choices you have. One is the Azure machine learning endpoint, that the one that you're seeing here, the real-time endpoint, or you could do Kubernetes attached endpoint. So those two are available. Kubernetes, you need to provision them separately and then attach to Azure machine learning. In this case, Azure machine learning compute is available out of the box. Docker, you don't need to provision anything. It's not related to your Azure machine learning. It will, what it will do is it will push that image to a container registry, and that's about it. But when you're looking at web app, it will deploy, as you can see here, it's a separate resource group. It's not related to Azure machine learning. It will separate resource group. It will deploy it over here. And once you come to its configuration and you see the URL, when you click on this is what opens, and then you can start interacting with it.
Okay, so to summarize, we can use AKS or standard compute with Azure Machine Learning. We can just push a Docker container and then choose a service that we want to use to deploy that with, or you consume it with a web app. Is that correct?
That's correct. And
okay.
It does not stop there, because once it's a Docker image, you can take it anywhere. You can take it to a function app. You can take it to an Azure. You can run it on premises as well, because it's a Docker image. It's a self-contained, and you can run it wherever you want.
And that's for my Promptflow solution, correct?
Yes. So you get the same UI when you run the container out of that image. You get the same thing over here. So if let's say new chat, you can randomly say divide 1000 by 5, and it should give you a response over here as 200. So this, you can take it anywhere down with you. So let's go through it step by step. So the first thing, after cloning and configuring, as part of the configuration, what I did, I chose to create a few things over here. So when you come to Promptflow, when you create a flow, your flow is dependent on connections. What are those connections? The connections are nothing but you want to connect to OpenAI, Azure OpenAI, right? Because large language models are there as part of OpenAI service. It's not part of the AML. It's not part of your Promptflow. Promptflow is an orchestration which consumes OpenAI services. So you need to provision them. And once you provision them, you need to create a connection for them. And when you have to create a connection, you can simply come and say, I want to create a connection for Azure OpenAI. And you need to say, give it a name, provide a provider name, give it a subscription. This is my subscription, for example, and then provide the API key and the API base and do this configuration. Once you have this configuration, we can use this within our flows. Let me show you how am I using this in my math coding. So within my standard flow, I have the flow DAG, and over here you would see that I have wherever I'm using OpenAI, there's a connection called OpenAI, and that's what I already have over here, as you can see it. Second thing that is important is a runtime, because when you're executing your experimentation and everything, you need a runtime. The two types of runtime provided by Promptflow, one is a dedicated runtime. The documentation to create a dedicated runtime is over here. So you can come to say, I need to create a runtime, how to set up a runtime. You can follow this process. Or the other way to do it is actually you can say, when you don't even create a runtime, just come to your flow and say, I want to use a automatic runtime. So in which case a compute will be provisioned for you, a runtime provision on that, and automatically you will be able to execute that. In that case, you don't have to provision anything in terms of runtime or compute for that matter. This repo supports both of them. So you can execute either on serverless runtime, or you can do it on a dedicated runtime. And so you need to follow these process. If you want to use dedicated runtime, then the steps are mentioned here, because you need to provision the runtime and the compute. If you don't want to do that, you need to make sure you're able to do some modification in code, and I'll show you what those are, and then start using it.
So when I think of like environments and runtimes, I can kind of think that as my Docker image container, right? Like, because that on the back end is the environment is a Docker image that's been customized for your deployment. So to kind of like, if just to kind of summarize what a runtime is, because I think at first when I thought about a runtime, I'm like, what is it actually? And you can just think of it as your Docker container environment to run your Promptflow.
Yeah,
right?
you are absolutely right. So I want to run this flow, for example. When I want to run this flow, I need something to run this. I need some binaries, bits and binaries, which will help me run this, and they understand what's written here, because this is a DAG file. This is a something like this. It looks like a DAG file, which is nothing but YAML. Who understands this? The runtime understands this. So I create a Docker. I have a Docker image based on Promptflow. I can bring all my dependencies into it using requirements file. And then I'm able to execute this tag file, which will take the inputs, execute the flow, generate an output for me, which will run as a flow with it as a job over here. And I can come and see this job. When I can come and see this job, I can see the inputs and the outputs as well. So as you can see here, I had some inputs, I have some outputs, and I can match them. So this is how the entire thing comes together. You have a runtime, you have a flow, you need to run the flow using the runtime. And when you run this flow as a runtime, it is attached to Azure Machine Learning using MLflow. It provides everything to Azure Machine Learning, and then you can see all the logs, everything over here automatically.
Cool. So we put a lot of pieces together, right? We created an endpoint that is deploying our prompt flow, that is creating an environment so we can both run it here and deploy it and have the needed
Yes.
packages that they need. We can deploy it as a Docker container. Am I missing anything? Probably am. There's a lot there.
There's a lot there. Yes, there's a lot of things that I've brought together and automated. So whoever wants to use it, their life become easier. So customers' life become easier, the user developers' life become easier. The engineer can simply take this repo, clone it, fork it, and then configure it. And let me show you how to configure that. So once you have this pull request, let me show you the first pull request. So my things have been configured. Once it's been configured, there are small changes I had to do to make it run. For example, I wanted to run as a serverless runtime. So instead of a dedicated runtime, I just provided my runtime, serverless runtime should be of this size. I don't want a dedicated runtime, so I just commented that and provided the size of my runtime. That's all. Once after this, the only thing I did in my deployment config, because this was an application I wanted to run as a web app and Docker container, I provided which registry I need to provide this Docker image should be stored at. So I provided my registry name, which resource group this registry is at. What should be the name of my plan? If you see this matches completely to this. So if you see this, it should match. All three of them should match here. All three of them should match the math coding plan and the math coding app, and also the UMID. And I wanted to provide a SKU. That's about it. This is the only configuration I had to do the deployment to get this end output over here and nothing else. So once I did that, I provided my LLMOps config, which resource group, which workspace I'm working on, and which is my key vault name. And that's about it. Once I did that, I did push my code to my feature branch, and my feature branch, then I did a PR from my feature branch to my dev branch, which looked like this.
So it looks like this repo has all the pieces that you need to put together. So there's a lot of things you have to put together, but then once it's working, it's going to simplify, it's going to add consistency, and it's going to give those things that you really want when you're deploying production solutions. Yes. So you got to do a little bit more work on the front end, but we've simplified it with the repo, which I put the link on the bottom here for people to go check it out and try it out for themselves as well.
So the feature branch, when it runs, it actually executes your pipeline. And this pipeline is nothing but this pipeline, where you do all the basic checks. You run the flow with the sample data based on the PR data mapping for the PR that you did, and will make sure that your PR is ready. And once you do the merge, once you start merging it, then your actual merge request runs for your named entity recognition. And here you will, let me take you through what are the steps it goes through, because these are part of the GitHub pipelines. What it does is actually logs into Azure, configures your agent with all the necessary binaries like Promptflow binaries and any other dependency that you might have. It registers the data that you have within Azure data assets, so that it can be versioned, it can be tagged, it can be referenced later on also, but it will only register if there's a change in data, otherwise it will not. It will execute your bulk run, which is your experimentation flow. And as part of this, as you can see, we had quite a few, the software engineer, same data that you saw before, and we were able to execute all of them. And then we evaluated. And when we evaluated, we what we get is the evaluation score for how accurate were our responses from large language model compared to what was expected. And those responses you can see here, that was an exact match, or partial match, or a full match, and things like that. So we were able to evaluate whether the expected and the actual output was right or not. And once it happens, then we went for a deployment. And when we went for the deployment, we almost had the similar things. But what you will see the difference here is that we register the flow as a model. So it's there for any time for me to roll back or to find out which model was deployed on which state as part of the CI/CD. I can always figure this out. Plus, I have deployed to an AML endpoint in this case, because this named entity recognition is running as part of your endpoint over here. This is running as an endpoint. So I deployed it as an endpoint over here. And once it got deployed, you see these were not used because they are meant when you use Docker images. So you see neither Kubernetes was used, neither connections and deploy to web app was used. Given a second example, if I go for a web app deployment, which happens to be a math entity, so in that case, we come back over here. If you go to math coding, you would see the difference automatically. You're no more using AML, but you're using local PF connections and you're using deploy to web app. And how does that work? So first, what you do is actually you make sure that you are able to generate the Docker image. For generating a Docker image, you go through a process, you download the base image, you run your requirements, whatever is requirement for your flow, and then make sure you put all the dependencies into it. After you put all the dependencies, you make sure the flow is available within the Docker image, because you need to run the flow eventually. And the flow is dependent on connections because you need to connect to OpenAI, and Docker image has no idea about the connection. So you need to create those local connections so that you can put those connections into the Docker image, so that when you run a container out of it, you will be able to use those connections automatically. So as you can see here, we have a new connection and we have a new node for local PF, a new image, and then we even run a container to test whether the image is working or not. And we send some sample data to it. The image is working after running as a container. Then we push it as part of the ACR. And once after pushing to the ACR, what we do is we run it as a web app and make sure we have a right configuration of the web app by making sure all the connections, all the connection strings within the app settings of the web app is also done. And then we also make sure we have all the necessary permissions, because we have generated a new ID for the web app. That ID is given permissions to read the prompt flow connections, runtime, and the necessary logging that it can do at various different places. We provide connections so that it does not fail. Eventually, it does the testing also within this part of the pipeline and make sure it happens. That's how this entire thing comes together. As part of the results, these are the kind of some of the output that you might see as a reports that are generated. And when you come to your pipelines like this over here, if you go for web if you go for web classification CI, you would see there is a complete package that gets generated as part of the reports. You click on this, this is what you will see here. For every run it happens, you can see that for each variant, we had multiple variants, we had multiple data sets. We were able to bring them together and see, compare them, whether it was matching or not. So the input was channel, but the output that I got was none. So it was not matching. It is incorrect. And based on this, I can come to a score as part of my evaluation. And because we have two data sets, there are two different evaluations. So we can see that the precision for this and the accuracy, there's a precision and accuracy we are doing it for. And we see 0.67 for basically variant 0. So variant 0 is good in both the cases compared to the others. And that's what we should be deploying. So we have two prompts. Variant 0 prompt is the best. I think that's the entire flow for LLMOps. And we can do this with GitHub as well as for Azure DevOps. We have a set of PRs coming in very quickly. I'll just take you through on the actual website. And you would be able to provision your entire environment as a private environment with no public access. That is something you would be able to do. You saw some of the data pieces into it, which were local files over here. Like, for example, these are local files, JSON files. We don't want them to be local files at most of the time as well. We have a data ops coming up in which you would be able to read data from various different places, do pre-processing, post-processing, and then save it in a data asset so that you don't have to store it as a local files. You would also be able to execute prompt flow as part of your AML prompt pipeline. So AML has a concept of pipelines, which you can use it to execute even your prompt flow. Then we are adding a couple of more examples like chat with your PDF, which is a RAG example, so retrieval augmented generation. And you also can use autogen like agents with this LLMOps template. So we are also adding that as well. So some of the things that are coming up as part of the new additions to the LLMOps template.
So that's awesome. There's so much in here for people to come in and start playing around and kind of pulling apart how they can start, updating their process, leveraging the features that we have in Promptflow, ML Studio, AI Studio, and kind of how those things all come together to give them a better solution, right? So there's lots of configuration to do, lots of kind of new concepts that kind of come into when you're starting to build these solutions with Promptflow. But then the output is that you're able to get some great testing. So we saw some of the outputs of what's actually working well. The variants are trying different prompts, right, and different models to see which ones are going to perform best for the different tasks that you have at hand. And that's a really important piece of doing LLM development, is starting to pick apart how it works, using evaluations, looking at the outputs, and then making updates and kind of iterating over that to get a good solution.
Absolutely.
So,
just one final point I would like to make. You can also do A/B deployments. And we did A/B deployment using a simple PR. And I will just show you what that PR contains. This PR has one single change. If you see this pull request, there's a small change in one file in that deployment. The only thing I had to do earlier, I have a prior deployment and I have a current deployment. And I just gave an allocation of 80/20, and it was able to do A/B deployments for me as well, so that I have two endpoints. And so I can pick and choose which endpoint I want to test. So I can come to test and say, hey, I want to test my green endpoint, which has a different prompt, or I want to test my blue endpoint, which is a different prompt. So you can come here, pick up your sample data. We provide sample data for each of them, sample request, just pick that data and you're able to test it out quickly as well. So if I come copy this, come here, I say JSON editor, I want to test my green one, come back here, paste it here and test it. So you see, I get data scientist and finance manager. And so similarly, if I take some other text and go to blue or similar text, I might get a different results. But in this case, since the prompts are same, I will get the same results.
So we can do some iterative testing as well within the deployed endpoint, as well as using the LLMOps or the actions, or you're using Azure pipelines to kind of test those out. So that was an amazing overview. So much to think about. I'm going to bring us two back in. Welcome. I think you had a few kind of additional summary slides you wanted to show, right?
Yeah, I think, it's tough to do after what Ritesh did, but I'll do my best on this. So what we wanted, right? So Ritesh talked about working with the endpoints, right? And endpoints in themselves are very powerful, right? So some of the other things that we didn't get time to cover, and something that we can the users can go out and explore, is working with the monitoring part of it. Now, with the model data collector that goes along with a lot of these endpoints, you can capture the data that's coming in and out, and then have some sort of metrics that sit on top of this, right? And you have this continuous monitoring that happens on top of your endpoints, which can inform, hey, how your models are performing, how your endpoints are performing. And this kind of gives you a right signal of when you should go out and improve your prompts, or improve your models, or improve the documents that are feeding into your RAG as well, right? So this is not something that we'll cover today, but something for the users to go take a look at it as well. And then lastly, right? Yeah, go
All right,
ahead.
I was going to say, because it's not just about evaluating while you're testing, it's also about monitoring and evaluating your deployed endpoints, which is super important to make sure that things are still performing the way you want. Maybe you find an issue that you didn't find with your test data set. It's not like the evaluation and monitoring isn't done just after deployment, right?
That's correct. And I think Nick had a question on the chat, right, where he was saying that, hey, can I use this to evaluate if I'm going from 3.5 to 4? Absolutely, you can, right? These pipelines, this evaluation pipelines can help you inform how your prompts are doing. Again, we use LLMs to kind of inform them of how your results are performing, but that's what these pipelines are for. It can help you evaluate not only against 3.5 versus 4, but let's say you're working with some of the open source LLMs, right? How do they compare with the OpenAI models as well? So they are fairly powerful, and something that everyone should go out and use it, specifically if they are playing around with various LLMs or even the same variants of LLMs that we come out with different versions of. So something to keep in mind and make it as part of your practice as you work with LLMs as well.
Yep, that makes sense. And also, when you're switching between LLMs, you need to think about how those LLMs get take prompts, right? Because sometimes when you switch to a different one, it's not going to perform well, but it might just be that you need to update how you're prompting it, and the
Exactly.
different kind of like tags and things that you're putting in your template. So think about those pieces when you start switching between different whole different models. With the different versions, you don't really have to change much for how you're prompting, because a lot of those take kind of a similar input, like if you're going from 3.5 turbo to 4.0. But if you're going to be doing a whole different LLM, take into consideration that in order to try to get the same results, you may need to update how you're prompting it too.
Right. And lastly, we kind of wrote a blog on the maturity levels of LLM ops as well. And our whole idea of kind of doing this is, as people play around in the initial stages when they are discovering the models, testing the prompt, we hope that, adopting some of the methodologies that we have shared in the accelerator, we'll share some links as well. We hope that you will be able to jump from level 1 of maturity level to at least level 3 or 4 while you're kind of working with this whole automated end-to-end model deployment and monitoring as well. So I hope this session was useful in giving you a perspective and how we kind of progress through each of these levels as we work through various applications.
I really like the levels here, because I think going from like 0 to 4 is a lot of work, and that seems like really intimidating, right? Because people are kind of learning and iterating as they're building. So I like that there's kind of these steps to get started, and also this template repo that they can go use. They can read the blog. I've showed some of the links as we've been talking, but so they can kind of start to figure out how they can start using this stuff, and baby steps, right, to get there.
Yes. Yes. No, this accelerator is a culmination of a lot of people and a lot of projects that we have done. So kind of has lessons learned that we felt were useful for others to kind of take advantage of. So yeah.
Yeah, just wanted to add here. It takes less than it takes few hours to set this entire thing up in its most vanilla format, and then you can keep exploring, keep expanding, and add more depending on your requirements. But to get started, it doesn't take much to get started. It's quite simple. It's just about configuration without code changes. And so it's all about forking, cloning, making sure you follow the configuration path to use it. That's all.
How hard would it be to update it to like my own solution? So like I see forking the repo, and I'll share that link again right now below here for people using that, following the instructions, getting set up in the services. That seems like a good, starting point. But when I need to start configuring that to my own solutions, is it pretty easy? Like, can I use a lot of the same things and kind of just flip out to my new prompt flow and maybe put my own data in? Or how much work is it for them to start updating this to their tasks?
It's actually the main work will be in developing your own solution, right? So you are creating some logic for your prompt flow. So you building that logic is the main work. Apart from that, bringing that logic over here is not a lot of work. You need to put those flows in the right folder. You need to put your data into the right folders. You need to do the configurations right, and that's about it. And then you have to just make sure you are able to run your GitHub or Azure DevOps pipeline appropriately. You do the PRs and configure it the way, because the way it's been documented. When you do the PR, it does the checks, validates, and when you merge the PR, it does all the CI/CD for you and things like that. So it's all about making sure you have the right logic in place and the right evaluation in place. You know where you want to deploy, and then just bring the data and the configurations. That's all. That's about it.
Awesome. So having that template is really going to kind of shortcut and help them get to that more maturity level faster.
Exactly. Because if you have noticed that when you have the math coding pipelines, the math coding pipeline does nothing but just provides parameters to the platform. So you just have to create a skeleton, just copy paste the existing ones and change the values in them, and that's about it.
Awesome. We had another question here that I want to ask you. It says, can semantic kernel plug in endpoint an option? So I think it's asking if they're able to use semantic kernel as an endpoint.
So the way you can use semantic kernel, for example, semantic kernel planner, because it's a package, Python package, you can obviously use it. You can do all that. But from a deployment perspective, we do not have a semantic kernel endpoint. We have the Promptflow endpoints and Kubernetes endpoints and web app, because we do Docker. And so, but if you have created your flow in Promptflow, which uses semantic kernel as well, for that matter, or LangChain for that matter, you can use LangChain, semantic kernel, whatever you within your Promptflow, they will go as a package and get deployed. So, but the endpoint will be from like a Promptflow endpoint internally using semantic kernel, LangChain, or Promptflow, or BU Vanilla, whatever it is.
Exactly. So I can put my LangChain code in one of the nodes or tools in Promptflow and then deploy my Promptflow solution. So it's very modular in that I can put whatever I want, any Python code, right? I can put in there and put together and chain together for my Promptflow.
Exactly. And that's what I talked about, that even AutoGen, which is an agents, we are putting them in Promptflow, and then we are deploying this. So when you deploy this to a web app, for example, you get the Promptflow endpoint, but internally it is using agents to make your job done. Similarly for RAG, similarly for even knowledge base. For example, if you want to use knowledge graphs with your RAG and things like that, you could do all of those. The capabilities are unlimited because it's all Python eventually at the end of the day.
That's awesome. I'm going to ask you a question that I get asked a lot is, when can people use C# or other languages? Is Promptflow going to stay mainly Python, or can we talk about what the plans are there?
Okay. For now, it's Python.
Okay. I get asked that every time I show it. That's why I'm asking you.
Yeah, for now, it's Python.
For now, it's Python. Okay, great. I want to thank you both so much for coming and showing this amazing demo, showing people how they can get started, maturing their LLMOps solutions, putting in their own solutions, using this template to quick start. Lots of good stuff there. We'll have the links, which I've posted below and in the description. So thanks so much for hanging out.
Yeah, thanks a lot.
Thanks for having us.